So welcome everyone to this Spark in the Leaf talk. The talk is going to be focusing around how we can model for Spark, or better saying, for high-speed processing. But more important than that is how we can integrate these two cool technologies that are MongoDB and Spark. Now, before we jump into that, I want to make a recognition here. Last year, I was here talking about big data. And probably some of you have been here and might got a little bit confused because either I was talking about big data or impersonating the grumpy cat. Both are correct, as you can see by the evidence on this picture. So this year, I'm not going to be impersonating any grumpy cat, but you might find it a little bit similar. But also, Big Data 2014 was great. And I wished I could be here the next year. So I call it the Wish-Making Conference. Because this year I'm here again, and I'm talking to you all. But this year I'm going to wish for something else, like winning the lottery or something like that. Otherwise, I need to prove that actually this is a wish-making conference. So all bets on that. So as an agenda, we're going to be talking about Spark, what it is a little bit, and how we can connect it with MongoDB. We're going to look into ways of connecting both technologies and what tools are out there that makes us make the most out of those two technologies. Some use cases where it can fit, and a little bit of a demo back in the end. By now, you should all know what MongoDB is, correct? Unless you've been living under a rock or you've been in a coma for the last 6 years, and you just came in and come to the conference. If you have been in those situations, I can explain to you very, very quickly that MongoDB is a document-oriented, open-source, general-purpose database. In essence, it allows you to pretty much build any kind of application with any kind of use case and using a document model to store your information. Now, this shouldn't be a very big problem because you work with object-oriented programming languages or even functional languages. You tend to model things into documents or objects, and the merge between them two is quite easy. The other good thing about it is that MongoDB is full-featured in terms that you have a lot of things out of the box. You have geospatial capabilities, you have secondary indexation, rich queries, you will be able to do aggregation framework and full-text search if you want to, out of the single instance in a scalable, highly available system. But the good thing here is that you concentrate on code. And this is where I want to focus your attention, is code will drive your application. Not only because it's actually the thing that's going to execute, but also in MongoDB, the way that you are going to store information. And we're also going to be talking about Spark. Now, just yesterday, before I was already wrapping up the presentation, and I've seen this post from MongoDB saying that Apache Spark, or Forbes magazine call it Apache Spark, the Taylor Swift of big data. Now, I took the opportunity to re-scratch completely my presentation and not going to talk about Spark anymore. We're going to be talking about Taylor Swift, which is much more interesting, I believe. It's much better looking, I'm pretty sure. Not at all. No, we're not going to do that. What we're going to do is explain a little bit what Spark at the end is. Now, Spark is composed by 4 main components. Spark SQL, which is a seamless integration between data processing ingestion in a distributed fashion using a data frame API. That you can also plug in, either use your own Spark SQL language or use something like Hive, which if you are familiar with the big data, let's say, environment, it's a SQL-ish language that allows you to manipulate data in a very traditional way, as you are all very well acquainted with. Then you have Spark Streaming, and this is probably one of the biggest hypes of Spark that allows us to ingest streams and process them in a stream way and do a lot of the real-time or near real-time big data processing. It's extremely useful, especially if you want the fault tolerance part in the equation. If you have a lot of Spark nodes and you want to make sure that if you are processing a tweet feed and counting, I don't know, hashtags or something like that, you will have a fault-tolerant application or infrastructure that allows you to support any particular hiccup that can happen in your distribution model or in your deployment. There's also mlib, which is basically the the machine learning library. It has a bunch of algorithms that you can put injection of lots of data into different streams of information, Hadoop data, and have it all processed by machine learning, again, in a distributed fashion, in a distributed nodes, and GraphX, which allows you to do all these complicated calculations of the distances and relations between nodes and all sorts of different levels. I'm not so familiar with mlib or GraphX because, well, you don't need to connect MongoDB to actually use it. What I do look into is things like Spark SQL and Spark Streaming. We're going to be looking into ways of putting data into MongoDB from Spark and getting data from MongoDB and process it in the Spark distributed model. So why do we need Spark in MongoDB, right? Spark has its own persistency layers, like it can directly talk to HDFS. It can directly talk to a sort of different databases. It has a lot of connectors. There's also one for MongoDB. But why do we need it? If we analyze data management in general, we're going to have these two different workloads that we need to address. On one side, we have the very heavy offline processing, the batch processing, the analytics, the data warehousing workloads. They are basically very, very dense. They generally are measured in not exactly gigabytes, but hundreds of gigabytes or terabytes even. And they are generally have a completely different focus. It's more for analysis, more for segmentation, more for the heavy lifting of data across multiple times and across multiple scenarios. With Spark, the offline gets a little bit grayer because you can actually do certain use cases 100 times faster than traditional MapReduce. And this is where it gets interesting. Because if you have a few terabytes of information and you want to do a big, big aggregation of all that data in response on near real time, Spark will probably be your solution. The other good thing is that Spark is not as heavy lifted or heavy dragged like Hadoop. Hadoop depends on HDFS for most of the things that it does. Spark doesn't. So you can have just a Scala distributed nodes that will process your data in a distributed fashion. And then you have MongoDB, where you're probably going to be storing a lot of the operational workload, the OLTP, like application data, fine-grained operations, real-time analytics, small counters, all those interactions that you're actually going to build your functionality on top. So this is basically the vision of where you should have your data management distributed across these two different scenarios. And there are things like delivering user relevance that, if you have a lot of users connected to your mobile application, you want to do recommendations or segmentation of that, probably you should have something like Spark or even Hadoop to do that. But if you want to keep track of everything, every message they exchange or every click they do, probably something like MongoDB is going to be much, much suited. Now, I thought about this, and I wanted to give you guys a little bit of an indication of things that could be useful. Like, for example, fraud. Now, let's say that we have a boy that communicates with a girl, or stalks a girl, I don't know, and sends her enormous amounts of messages. Now, he might think he's talking to a girl, but he might be talking to a bot, or some process online in Nigeria, some server, you never know. And obviously, all this is very engaging. You might have millions of users, and a lot of them are exchanging, "Hell, I love you." The bot will love that and says, "Oh, yes, me too. But give me your credit card number, please." You might get a little bit confused, but since you are so in love, you'll end up doing it. Now, this is another scenario of fraud. You might think traditionally that fraud is mostly around credit card payments and all that, but this is another scenario that you want to analyze in real time, workloads of an application operational database. Now, if you have just a single pair or a couple of pairs, maybe you have a bot in the middle, it simulated some information injection, some messages, you never know, you won't believe this is the situation. This is quite easy to find because you can use the workload of the operational set very, very easily. But if you have millions of communications and you want to analyze the whole traffic of the system or what is happening in real time, you will have a problem if you're starting to use your operational database to do that. And this is where we plug in Spark. Your chat application might want to use the traditional workload for the messages, the user profile, the contacts, and so on, all in an operational database. That's fine. MongoDB can do it. Even some real-time aggregation, you can also do it in MongoDB. It will not be as heavy. But everything related with fraud detection, segmentation, recommendation engines generally needs a lot more data. It needs historical background, needs a lot of information on the total amount of information that is being exchanged through the chat servers. All of that might be relevant. So you need to take decisions based on that. Spark helps because it bridges the amount with the capability of processing that in a streamlined way. And there are a lot of different use cases where you can have it. You have the wearables. Who here has an Apple Watch? It's useless, isn't it? But it collects a lot of data, and it collects a lot of information that you might be finding relevant in the future. Like, for example, you want to analyze how much a clinical procedure, how much did it influence your mobility, or you want to track if you're training for, I don't know, a marathon or something like that, you might want to track your evolution over time and so on. So that can be all done by operational database. But if you want to check across your peers or check and analyze what would be more recommended for you for a particular different training or whatever you're doing with that wearable information, that could be done. And that's where these two technologies come together. Another quite common scenario is to analyze problems on prescriptions. Doctors prescribe you drugs. Drugs are good. They used to tell me when I was a kid that drugs are bad, but they're not. They make you high, so they're good. But the other thing that they do, they cure diseases and help you get better through when you have a headache and so on. And once you are over a medical procedure, intense medical procedure, like you're hospitalized for a surgery or something like that, mistakes need to be avoided. And every time someone prescribes something to some patient, we need to cross-check it against a lot of other uses of the same prescription, or the other way around, across the particular procedure, to see if a particular medicine has been prescribed or not. So a lot of these things, including clinical trials, access to complete patient history, and so on, these are the scenarios where you're obviously going to bridge the historical data with the actual data to make smarter decisions. In MongoDB, if you want to use MongoDB alone, for high-speed ingestion, so MongoDB being on the front line of your massive IoT scenario, or massive TIC data, or financial institutions data, sometimes we need to model according with the requirements on speed. So we have a lot of updates on a single document, and you want to make them as fast as possible. In traditional MongoDB 2.6 and 3.0 MapV1, you would use something like this, which would be a time series use case. You have some resource, like in this case is the stock of Microsoft on day 12. You would have the type, it's the open ticks, so the value of when they open at a given moment. You'll have the date, and make note about that date. It's 12/07. This is my birthday, so be sure to send me regards when this happens. And you'll have series of data that will be accumulating over time. So what we have is per hour, on a particular minute, how much, what was the value of that tick at that time. This will allow us to immediately plot very, very quickly all the information that we need, but more importantly, we'll be constantly doing in-place updates, which in MongoDB MapV1 is extremely fast. Now, this might be not the best obvious use of a document, because we generally think about documents as structures or units that happen. So you probably think about things that will accelerate all of this. We have now a new storage engine called WireTiger, which allows us to do that. Now, speed, when we talk about speed, we're really talking about speed. And the talk about speed is this kind of speed. This is a comparison between different workloads with YCSB of MapV1, or better saying, MongoDB 3.0 against the blue one, 2.6. So if you're thinking about, well, you know, I have this instance in 2.6 in MongoDB, it's stable, it works, but sometimes the speed is not there, WireTiger probably is going to help you a lot. It's the difference between doing 35,000 inserts per second to doing 200 or 300,000 inserts per second. When we're talking about very high-speed document ingestion, we're really talking about very high speed. If you want to boot it up and get it started, this is the way to do it currently on 3.0, which is our latest version. In upcoming version 3.2, it's going to be the default storage engine. So get ready, prepare, download it, test it, see if it works for you guys, especially on workloads that you have a lot of writes coming into a big, fat streamline of information. And if you have one of these use cases, it might give you an indication where mmap is actually going to be good, like very high reads, like content repositories or customer analytics. But if you have all the IoT, wearables, Apple Watch kind of stuff, or if you have FS, to track all the ticks, or even doing archiving of data, you're probably going to have major benefits of using with WireTiger instead of mmap P1. There are a few more that we are working on, like an in-memory one and an encrypted native one. So be prepared that 3.2 is actually going to be having a lot of news on this field. OK, but let's get back to Taylor Swift. So Taylor Swift has this, Spark has this streaming mechanism. And the streaming mechanism is often represented like this. We have an API or a service that's constantly bombarding us with information. The typical example might be the Twitter Firehose application or API. You just have a stream of information, user-generated, that you can capture it all. You might want to capture it all, do some data analysis with it, and then store it for application purposes in MongoDB. So you might receive something like this. This is the example of a tweet feed. It will have a lot of information in it, like the coordinates, created when, where, who did it, when did it do it. It's quite long, and I saved you the trouble of putting all the information there. You pick up this information, and you transform it in the fine-grained data that you want, like, for example, counting the number of different hashtags that you have. So you have per unit of time, let's say every unit of 5 minutes, I want to aggregate the number of hashes and the amount of times they are being hashed, or basically emitted in the tweets, over time, over that period. So if you have a lot of them, you're eventually going to be updating the counts. And this is all in a distributed fashion using Spark nodes, which is great. Then you can store them all in MongoDB. They come as fast as you possibly can do it. And if you have some kind of real-time analytics or plotting what is going on Twitter in terms of hashtags and how popular they are per units of, or per buckets of 5 minutes, you could probably put this into a capped collection, have a tailable cursor, something that is native to MongoDB, that is constantly open, and every time it receives a new write, it immediately notifies the reader that, hey, there's new data here, you can plot it. So this is a way of completely streamlining an application of having some data injection to Spark, from Spark to MongoDB, and that to the end user. Very fast, very straightforward, very simple to implement. The other part is Spark SQL, and this is probably the one that I would say 90% of the users of Spark are actually going to be using. The traditional way of connecting MongoDB with Spark would be through the Hadoop connector. We have a specific connector for Hadoop that basically allows you to get some data from MongoDB, process it into Hadoop, and store it in HDFS. After that, you can query it using either Spark SQL or some other thing like Hive. The other way around also works. And this gives us a lot of options in terms of complementing data from your operational data sets to your analytical and data warehousing and data sets and merging them together. So you enrich each other quite often. Now, this is quite good, especially if you already have an infrastructure all set up using Yarn and all the other Hadoop components. You can use this one because it's actually already there. You can express your queries in Hive, you can express your queries in Pig, you can express your queries in even Java vanilla MapReduce jobs, and it will work just fine. And if you have a Spark connector on top of that, you want to do some streamline of that or some extensive fault-tolerant application counters, you just need to connect it to HDFS. Now, there are some positive things. It's battle-tested, it's heavily tested, it's been very, very well used for a lot of people. It integrates with the existing infrastructure. It doesn't support fully all bucket types and all data types of Hive, but it's coming in the upcoming releases. But the major thing is it's native to Hadoop. It talks the same languages that you use right now to actually express queries against HDFS, for example. The part that's not so good is that it's if you want to integrate it with Spark, it's not native to Spark. It doesn't speak, for example, Spark SQL, which is a variant of the language that allows you to connect to a Spark node. It also is not the fastest thing available, and the biggest problem is it's dependent on HDFS. You need to have it to make it actually work well with Spark. Now, there are these guys, I don't know if you heard about them, they organize these kind of conferences called Big Data, Spain and all, which are called Stratio. And Stratio, they have a lot of different components. They are heavily invested into making the Spark ecosystem work well, and they have a specific connector for MongoDB. Actually, if you go to Spark packages, which is basically the Maven repository for Spark connectors, this is the only thing that happens to be there for MongoDB. So no one else in the world does a connector from Spark to MongoDB, which is good, and I salute you. The way it works is that immediately it ditches completely HDFS. It doesn't really need it unless you actually want it. It does ingestion of both sides. So you can have data processed from Spark, directly flushed into MongoDB. You can pick up data from MongoDB, process it in Spark, and put it somewhere else. Or you can put it even again in MongoDB. We're going to be looking to a practical example of doing that. The way to work, well, simple. You need to build a configuration. It comes with a lot of helpers in the library that you can use. Here, the MC input builder is just telling the system, hey, you need to fetch this particular data out of this database, out of this collection, with this sampling radio, to know exactly all the differences between the different documents. As you may know, MongoDB is flexible, so you can have all kinds of different documents, all kinds of different structures inside the same collection, so sampling ratio will allow you to check for differences. Here, they are all going to be homogeneous, so I'm just going to keep one. And I can also tell it, if I want to write back, I can use it, and I will use MongoDB native write concern system. I create the configuration, read the input, and I'm ready to rock and roll. The next thing I need to do is create a context. Here, I'm creating a Hive context. So it's also something good. We allow us to map into this particular application if you're already using some Hive queries to actually query data that you want to have in that particular format. You can use that. And then you just call it and save it to MongoDB. The good thing about Spark connector, Stratio Spark connector, is that it actually knows and deals well with the fact that you can have a sharded collection or a sharded cluster. So what happens with MongoDB when you want to scale out, meaning that your single nodes cannot hold for all the data that you want to deal with, you just add more shard nodes, and that will give you a normalized and a horizontal scalability model. As much data gets in, you just add more nodes. Now, one thing that can happen is that this can be the bottleneck. If you have a distributed Spark instances that span across multiple regions on Amazon, for example, and if you have one centralized way of fetching data, then you're not going to be benefiting that much from it. So if we have something that knows how to do this, mapping the different regions of the Spark nodes back directly to the local nodes, that is going to give you a lot latency gains. So you'll have almost no latency between all the nodes, independently where they are. This is something that Stratio connector implements, and it works like a charm. Actually, this is something else, something that the MongoDB connector also does, or tries to do very well. It's making sure that the data that you are transforming or processing is local to you, and you can use it directly. So this is something that Spark and Stratio guys did very, very well. Okay, so I see a lot of boring faces, so I guess it's time for us to just do a small demo of, and this is me when I get home, by the way. I just don't have that kind of hat. That's the only thing I'm missing, but the rest, the tie and all, yeah. So what we're going to do is the simple thing. We're going to put some data in MongoDB, collect it, process it in one single instance node Spark, and retrofit it back into Mongo. So for that, I'm going to use something that everyone likes, which is the notion of money. Am I right? Does anyone here doesn't like money at all? Okay. I also find it dirty from time to time, but I use it to buy beer and stuff. So what I have here is msft.csv. It's a CSV of
all quotes over a given day on the per minute instance of all the open, high, day, the timestamp when it happened, the day, the open value, the highest value, the lowest value, and the close value of that stock. And also going to have the amount of shares interchanged in the market. Now, if I want to load this into MongoDB, just to show you I have a MongoDB running, this is the way you connect to Mongo. There should not be any database there. It's empty. It just has the default one, which is local. We don't use that. If I want to import data into MongoDB, everyone knows how to do it, which is to use Mongo import. I tell it which database I want to use, which collection I want to use, and the type of the format of the data that I'm importing, and there we go. Once I imported all of this, it imported 97,609 documents. If I connect again to MongoDB, I can tell it immediately which database I want to be using, Big Data Spain, show collections, and there it is. So my collection is called minbars. If I go there and find one, I can see that there's exactly the same information that I'm storing per each line of the CSV, everything in it. So it's very straightforward. It's not very complex. It's on root level. Has a little bit of information on it. What can I do with this information in terms of operational workload? Well, there are these things called web apps, like one that I have here. Let me just do it, app. And I have a small, oops. There we go. I have a small application that does one thing, exposes one root, and every time I call min_ticks, it will go into my min bars, this is the collection, collect 150 elements of that with a find to that, which is a simple projection. I encode it into JSON encoder, and I put it on the front end. What I do with it is basically, if I put it up and running, I do something like this, which is, just to show you, if it lets me show, oh God. There we go. If I refresh this, what it allows me to do, oh, now I need to change the database name. No, it's already there. I love it when you have these moments of friction between what you actually want to do and what actually is being running. So it should map everything here. I don't know why it's not working. It's not mapping. We'll try it the other way. Well, the idea is that I will map and graph all of that information. I'll check it out what is happening. But what I want to do is not to show it per minute. I would like to show it in a per 5 minutes interval. To do that, I have this other application here, or script, that will allow me to do that in Scala. Now, what I'm going to do is launch a Spark shell and run this code. This code is very simple. It does its normal imports of all the dependencies where I want to use. In this case, can be either jars processed in Java, like the MongoDB jar that connects to the driver. The Kashpa is our driver for Scala. And then you have the providers for MongoDB, which are all bounded to Stradio. So to do this efficiently, what I need to do is just call this particular shell over here, which I call Big Data Spain. If you are curious to know what it has, it's very simple. It's just calling Spark local, so Spark shell, and passing on all the jars that I need to actually load all of this, so I wouldn't have invalid imports. Just going to run this. So I run the Spark Big Data Spain, put all the information there. Here we go. It loads a lot of things. It creates a context. It creates a Scala context, so we can use a lot of the information that Spark will give us. And now we can just start copy-pasting. So what I'm going to start doing is import the data, or create all the imports. So if we've done well the imports of the launching of our Scala or of our Spark shell, this should not have a problem. After that, what I'm going to do is tell it which database I want to use, and I want to build that builder that's actually going to give me where I need to fetch my data and how I can get it. The database, the local host, the collection, the sampling ratio, all of that. I copy-paste it again. There we go. So I create the variable for the big data Spain, config. Then I tell the builder to actually create a configuration, a read configuration. Done. After that, what I tell it is, well, I'm going to run a Hive query, so I need to create a context for it. SC is the context that's created by the Spark shell. I define which database I want to read from, which I configured at the read config, and I registered the template. I'll do that. There we go again. All right, all created. Immediately starts connecting, understanding what I'm talking to, registering the documents, trying to see what actually it has. Once it's registered, the only thing else that I need to do is basically express my query in Hive. Here, as you can see, what I'm doing is creating this particular symbol, open time, timestamp, open, high, low, close, and volume data. I'll select it from the table that I'm using, which is min bar, so minutes, bars per minute. And I'm going to be grouping, in this case, getting the first value when I do a partition of that collection on that particular field. Okay? If you're not too familiar with Hive, this might sound a little bit strange if you're coming from native SQL, but this is the way that we can do all of this information. And we just need to copy this. Here we go, the SQL context. And we run it. And once we run it, it will do all the configuration. So it's ready to run. And we just need to tell where we want to write. Now, I will create this 5-minute bucket that is an output configuration. I'm just going to tell it exactly the same thing as in before, which database I want to write to, which collection. In this case, I'm going to write to a different collection, and the write concern and all that. Create the build, and call this save to Mongo. Once I do this save to Mongo, the system will lazy load all the information. We'll start aggregating all of that in Spark, and you'll see a lot of fetches. So the process is starting to compile that data, reading it from MongoDB in that particular processed way, aggregating in intervals of 5 minutes, and then storing it all into the collection that that I just created. If I show here the collections, you'll start seeing that I have now a 5 min bars, but it's completely, basically, has nothing, no data there. So it just created when I registered the template. And once the Spark is completely done, aggregating all the data, it will just throw it all into MongoDB. It will take a little bit of time. In the meantime, I don't know why this is not working. I'm really unsatisfied with this. I really like to have this. I want to show it all. It's called min bars, so it should be correct. I'll save it. And it should work. There you go. So it actually works. If you've never seen a stock tick counter, this is the candlestick graphs that it gives you the differences between the high and low value and the mean and the total. And the blue line is the volume of shares interchanged on that day. This is, as you can see, I don't know if you can see it very well, this is in a per minute interval, so we have 11, 15, 30, and 5 numbers in between. So that means that we have this stream of information coming. This is all great, but what I really want to do is actually put it on a 5-minute intervals, and the 5-minute intervals is basically changing the collection to use the 5-minute bars. There we go. Here we're going to have a lot less information because it's all condensed in 5-minute intervals instead of 1-minute intervals, so you should have a fifth of the information. And once you just change the database from using this to using this one, and you put it up and running, and you call it again, you will see almost no difference, except for the range here will be a little bit different. It will be in buckets of 5 minutes. Okay? So if you want to build your streamlined application that immediately ingests into this particular applications, you can do that as well using Spark streaming. It's just a question of choosing where you want to read data and how you want to read it to. So yeah, hooray, we've done a 5-minute interval processing from 1-minute interval processing through Spark back to MongoDB, and we are all happy, correct? Are you feeling powerful now? I hope you are, because this is absolutely power at your hands. I don't know if you guys are familiar with Scala. Scala is a cool language, but no one really knows, apart from a few people, what to do with it. Spark is probably the best reason to learn Scala, because it will allow you to have a native, very fast integration with a functional language in a distributed fashion. So be aware for that. So how about the future? What will the future unfold? First of all, we are working on a dedicated Spark connector. Not that we don't like Stratio, we do like it a lot, but it has some kind of, a little bit of a limitation. There are some limitations in terms of the actual Spark SQL compatibility that I've been told it should be already solved by a different module. I need to check that, but I'll believe it. There are some specific MongoDB operations, like the aggregation framework, where you will benefit a lot in terms of speed, in terms of performance, if you run it on a database, because it also runs in a distributed fashion all over the cluster in MongoDB. Today, we don't have that capability. We want to integrate it in our own. And obviously, we are working on a very, very strong async driver for all these streams, for all the stream workload that will benefit a lot the integration. So this is the major goals for the future in terms of integration with Spark. I'll be talking about, oh, not me, actually a colleague of mine will be talking about a lot more use cases and examples in London. If you want to come over, I'll buy you a beer. We're also looking for people, so if you are interested in moving and working for the guys with the leaf and calling themselves Mongos, I mean, it's not very popular, as you can imagine, but it's cool, it's a good company. Make sure you use this referral, because I'll get money if you get in. And I'll be around for questions, because I don't think we have time for more. So thank you so much for coming.